Well, that looks pretty nice, but how did we get there, and how well does it work? Hi, I'm Dan Cortopassi. Welcome to DCC Shop. In this episode, I'm going to continue to install DCC and sound into a Kato HO-scale NW2. In the first episode, I showed how to disassemble the model. I talked about planning the installation. I made new headlights, and I serviced and rebuilt the trucks. My goal for this episode is to finish the installation and get this thing running again. Before I start putting the model back together, I did a little prep work on some of the parts. I redid the Kato tape in here because I went with my motor tool off camera and enlarged some of the holes that I'd made for the wires, just to neaten them up a little bit and make them less sharp so that it reduces the chances that the wires are going to get cut by the frame. So just as a precaution, I added some Kato tape in this area to make sure that the speaker doesn't have any chance to short itself out on the frame. The way I'm setting the model up, the frame should be electrically inert. So this Kato tape, all of this is really just a precaution, but it's better to be safe than sorry. Another thing I did was to file a little material from the inside edges of each frame half to make a little channel for the wires that go to the rear headlight. When I had DCC in this model the first time, I actually tucked the wires into the gap between the frame halves that go to the rear headlight, but then I had to put the cab on after, and it was kind of convoluted to get the thing back together. So I think this time what I'm going to do is to very carefully route the wires down the center of the shell, and with this little V cut in there, there should be plenty of clearance. Another thing I did off camera was to solder new leads to the motor, the gray and the orange wires, and I also redid the Kato tape around it. And again, just like with the frame, this is just a precaution. I also soldered leads to the speaker. The last thing I want to do to prep the speaker is to use a little bit of clear RTV silicone to seal up this gap that's in the center between the two halves of the enclosure. I don't know how much air would actually come out of there, but it's good for enclosures to be sealed. This isn't really a detailing video, however, some things just make more sense to do while the model is disassembled. One of the things I want to change on this model are the molded-on windshield wipers, which I think just don't look very good. As you can see, there's two wipers in the front and two wipers in the back, basically on the upper side windows. Those are the ones I need to get rid of. I'll start by masking off the windows that I don't want to touch. I'm also going to mask around the wipers for the initial cutting. Now that I've got them masked, I'm going to take a chisel blade, try to shave off as much of this as I can, hopefully without gouging the rest of the window, which is why I use the tape. This is a little improvised sanding block that I made. It's a piece of 400 grit sandpaper wrapped around a piece of 40 thousandths styrene. So it's stiff enough to hold the paper pretty flat, which is what I want because the window should be flat. And now I'm going to sand it. Trying to sand it as flat as possible so that I'm not making the edges curved or sanding a depression into the center. So I got one side almost gone. The trick with this is just to work slowly and be patient. So not really a trick to it. The other trick to it, if you could call it that, is to stop once you can no longer see any traces of the original wipers. Now I'm going to sand it again with 600 grit paper. Just want to do enough to get rid of the bigger scratches from the 400 grit paper. I'm not sure how well this shows up on camera, but the window on the right has been sanded with 600 paper and the other one is just with the 400, and the one on the right is a lot clearer already. Now I'm going to continue with some 1500 grit. The trick is to just keep using progressively finer grades of sandpaper until the window's shiny again. Regular hardware stores don't always have these super fine grades of sandpaper, so sometimes automotive shops will. I worked my way up to 2000 grit, and now I'm going to switch over to these sanding pads. I think I got these from Micromark, but they come in super fine grades. This one's 4000. I think this came out pretty well. It's nice and clear again. Took a little while to polish it to this degree, but it was worth it. The front looks pretty good too. I'll talk about the little notch that I made in this thing a little bit later. Slight change of plans. I was looking at my reference photos of 608 from Portola, and apparently there aren't any wipers on it anymore. So instead of drilling holes in the cab like I was planning to put some aftermarket wipers, I'm just going to leave them off, which is fine because that's less work. So the first time around when I had DCC in this thing, I used the original headlight bracket that was inside the cab, and I put a 3mm warm white LED in there. Even though I'm not using this to hold the LED for the headlight anymore, I think I can still make use of it. So this model doesn't have a super detailed cab interior. However, I thought maybe I should add a cab interior light anyway. I think they have stuff like this available commercially, but I went ahead and made my own. This is another 603 size surface mount LED, and I've just glued it to a piece of square styrene that I cut. It's 40 thousandths black styrene. I use black to help prevent light leaks. And I just drilled a couple of holes in it and pulled the magnet wires through, and then used some CA to affix the LED. I used Same Stuff by Micromark, which is a plastic welding type of liquid styrene cement, to glue the little plastic square that I cut into the headlight holder. So this is the part upside down, and as you can see, the LED fits nicely into this rectangular opening. I threaded the leads for the rear headlight through the opening. I'm using some canopy glue on a piece of scrap wire to kind of put a little bead of glue around the inside of the headlight casting so that I can insert the headlight that I made and secure it. It's a good idea to test the headlight to make sure it still works. This looks good. I used the same technique to install the front headlight. I really like the way these look when they're off. As a precaution against light leaks, I'm putting a little bit of black paint on the back side of the headlight lens. I'm using some black on the inside of the cab roof as well. I don't need to be especially neat because none of this is going to be visible. Since the only colors of magnet wire that I have are red and green, I'm using green as the positive, so basically green is like blue for normal DCC color coding, and then red is the function lead. Now what I want to do here is cut this short, and I'm going to put the resistor actually in here. So I'll cut that. So the way this works, you have to heat up the end of the magnet wire and then start tinning it with some solder. I don't know how well this shows on camera, but the end of that wire is now silvery instead of red. That's how you know it's tinned. So I've taken a piece of the smallest heat shrink tubing that I have and put that over the wire, and now I'm going to solder a pre-tinned resistor to the end of the wire. Now I can use the iron to shrink the tubing. Sprung tweezers are helpful with jobs like this. Just putting some heat shrink tubing on the other side after soldering some more magnet wire to the other end of the resistor. This is a 1.5 k ohm resistor, by the way. I don't use any formulas for resistors. I generally use something between 750 ohms and 1.5 k ohms. I haven't noticed any difference in brightness, at least none that I can see with my eyes. And on this particular engine, I'm using the 1.5 k ohm resistors just to give them a little bit of extra protection, because I really don't want to have to take this thing apart later to fix any burned out lights. So I tucked the resistor over on the side here, and then I ran the wires through this little slot that I'd cut previously. This is where the original headlight wires came through, and I'm going to use them for the same purpose again. I soldered a resistor on the headlight lead as well. So it took a little finagling, but I was able to get all the wires tucked into this box. Now I just need to put the glass back in to hold it there. So I got everything back in, and I twisted all the wires together and then painted them black so they won't show too much, hopefully. So I had a couple reasons for putting the resistors in the cab roof instead of inside the long hood of the engine. One is just to save space. You know, there was room in here, so why not? The other is kind of an insurance policy to make sure that there is a resistor and that I won't accidentally hook up one of these leads without a resistor on it and then blow out my headlight or something like that. This cab interior has some holes in it that aren't stock. I did that for wire routing. Now, originally, the wires from the headlight came down here, and I'm still going to use that. And then they came through here and into here, and this was kind of a box where I wound up and kept slack, because I had actually put the long hood of the engine together first, and then there were wires sticking out, and I had to make the connection out here and then store the slack somewhere. That was all kind of really tricky to put back together, so this time I'm doing it differently. I don't think I'll need these holes anymore, but I'll still use this one. When I was working on the glass, I mentioned this notch and said I'd explain it later. It's basically just for wire routing. And I did this the first time I had DCC in it, but it'll still work for this one. So as I put the interior in place, I need to be careful to make sure that the wires come through this little notch. The magnet wire is a lot smaller than regular wire, even like 36 gauge wire that you'd use with insulation on it. So it doesn't show as much, and having the black paint also helps a lot. So this little piece of wire here isn't going to be very visible in the finished model. This is another notch that I cut for wire routing, so I'm going to use this when I put the cab back on the model. When I was talking about slack, I actually had the wires coming down and wrapped around this as well. It was a very tricky prospect to get all that back together. So I think doing it this way this time is going to be a little more straightforward. So I pulled the wires through, and now I can very carefully fit the cab back on the model. Make sure the handrails are out of the way. The handrails are not stock, by the way. I had to make those. There we go. So now the body's back together and all the lights are installed. I'm going to turn my attention to the chassis next. Now I can start rebuilding the chassis. If you recall, when I took it apart in the first episode, I paid attention to where this white dot was. So I actually had to go back and review the video to make sure that I got it back in the right orientation so that the engine will run in the right direction. Anyway, this isn't fully seated yet. I have to add the worms next. These have no lube on them whatsoever, and they still work really well. I'm almost tempted to just leave them that way. Sometimes the lubrication on the worm shafts or drive shafts can get congealed if it gets really old, and that actually makes the locomotive run poorly or not at all. So there's nothing to clean off here. They're totally clean. I'm going to use a very, very little amount of this Labelle 106 grease. This is plastic compatible grease, so it won't hurt the bearings. I'm just using a screwdriver blade to put just a very small amount. And I'll rotate the bearings to spread it around. Honestly, the less the better. Another thing I like to do is to test to make sure that this little connector on the end of the worm shaft is firmly in place. So it shouldn't rotate relative to the worm. Now I'm not forcing it really hard, just very gently, because I don't want to twist it and cause problems. If this was loose or cracked, it could spin without spinning the worm shaft, and that would make the engine run probably pretty badly. So it's good to make sure that this is correct before putting the engine back together. This little thing that almost looks like it came out of a Lego Technic set is the connector that connects the end of the worm shaft to the flywheel. So this is very important not to lose. There's two of these, one on each worm shaft. So now the motor's in place and the worms are in place, and I can rotate it and everything's smooth and I'm not hearing any scraping noises. It's important to make sure that the flywheels aren't touching the frame at all. They shouldn't be. There should be just enough airspace in there for them to rotate without scraping. I noticed there was a little bit of excess solder on the speaker connections, so I'm just going to file that down a little bit. Something that I forgot to do earlier is to cut a notch for the wires coming from the trucks. So I'm going to do that now. Would have been better to do this before, but that's okay. I cut notches here and here. These might be a little hard to see on camera, but these are big enough to allow two wires on each side to pass from the outside to inside the fuel tank area, where I can route them up past the motor and up to where the decoder is going to be. The interior of the fuel tank is more or less where this larger rectangle is that was, originally the weight before I carved it all away. This is just the remnant. But this fits inside, so when I put the speaker in, I have to make sure that it's within the borders of this piece of metal right here. I'm going to orient the speaker this way with the actual speaker closer to the middle and the enclosure out here. I'll use some double-sided tape to mount it. And I'm going to actually put this on before I put the frame all the way together. This is a little bit of a convoluted install, but I don't really see any other way to do it. I'm holding the speaker in its approximate position, and the contacts are against the Kapton tape, so I think everything should be okay as far as being insulated. I peeled the backing paper off the foam tape and then repositioned it so that just half of the tape is covered. I've mounted the speaker in the model, and it's flush with this edge here, And it's also flush with the back of this metal piece because this is the extent of the fuel tank on the inside. So I need to make sure it fits in there. I put the old fuel tank on temporarily just to check clearances, and there's just a little bit of space between the bottom of the speaker and the inside of the fuel tank, so I think we should be fine. I'm feeding the wires under this part of the motor mount and then around the motor. And then through the top the same way. The plastic part at the front of the motor is a little bit thinner than the metal part back here, so that's why I routed the wires this way. And I've left a little slack at the bottom just to give me some room to position them when I put the whole thing back together so that I don't pinch them between the frame halves. One thing I did in the old fuel tank that I forgot to do in the new one is cut a couple of little notches on the ends so that the wires from the trucks have somewhere to go. So I need to do that on the new fuel tank. I'm putting these between the boxy middle part and the outer part that has the air tanks on it so that they won't show. These are a little hard to see, but I cut 4 notches, 2 on each end. When I rebuilt the trucks, I soldered the wires so that the ones from the rear truck go forward and the ones from the front truck go backward, and they'll meet inside the fuel tank. It's very important that the wires are color coordinated so that the red is on one side and the black is on the other side on both trucks. This is a little hard to show on camera, but what I'm doing is the wire from the rear truck is going to come through that notch in the fuel tank and go along this little depressed area inside the actual frame and then up to the front. The wire from the front truck is just going to go directly into this area, and they're all going to go through up and around the motor. So at this point I have all of the wires from the bottom of the model routed around the motor and up to the top. I was careful not to let any of these wires cross, at least not initially, because if they cross they're going to take up more room. So if they're all flat and next to each other like this, then they are thinner, and that'll help me get the frame back together. Now it's time to try to start putting all this together. Put the 2 frame halves loosely together, and then I'll have to insert the trucks before they're totally clamped. I put the frame halves back together and I'm tightening the screws to make sure it stays that way. Now I'll very carefully pull these wires one at a time to take up the slack. As I mentioned, the wires from the rear truck get tucked in over here. They can't be too tight because the truck has to turn, so I think I need to back that one off a little bit. So as you can see, there's a little bit of slack in these wires, and that's okay because that'll get put inside the fuel tank. Also, I moved the speaker a little bit forward of where it was just to have a little bit of airspace so that the sound can get out the rear slot in the fuel tank, because I realized this was blocking that with it all the way back. Before I go any further, I want to make sure everything works. I've hooked the orange and gray wires to some test leads, and I have this connected to a DC power pack. Yeah, it's running. By the way, I had the engine test running on these little rollers from Bachmann, and they work pretty well. I think this is the first time I've actually used them. This still looks a little messy, but it's actually getting pretty close to being done. So now I need to install the fuel tank. I've arranged the wires as best as I can without anything holding them. After making a couple of attempts to put this on, I realized I needed to make a couple more notches to get the wires in. So I cut a notch here on this side and here on this side, kind of on this flat part of the inside of the fuel tank that won't really show. All this is going to be pretty much hidden, but it's important for the wire routing. And it's important, to be adaptable so that, if things don't go exactly to plan, you can come up with some kind of solution. All right, it took a little fussy work off camera, but I did manage to get the fuel tank back on. The trucks have enough slack in the wires that they can pivot. So I think this is good. And this actually fits tight enough that I don't think I need to glue it or anything. It's just held on with friction. Before I go any further, I'm testing all the track power connections with a multimeter just to make sure everything's still okay. Looks good. The decoder I bought comes with this ribbon cable, which I'm not going to need, so I'm going to cut that off. Instead of that, I'm going to use the solder pads up here in this area, and to get to them I need to cut some of the shrink wrap away. The decoder comes with a booklet with a bunch of different diagrams. The LokSound micro diagram is the one that's relevant for this particular install since that's the decoder I'm using, and the diagram shows where to make all your connections. Most everything for this install connects up here on this part of the board, and there's already some wires pre-installed for me. This part down here is where I connect the power pack. This was too fussy to do on camera, so I did it off camera, but I soldered the power pack to the decoder, and then I used some double-sided foam tape to mount the power pack capacitor right at the end of the frame here, because that's where it will fit. And I've determined that the decoder is going to have to kind of go at an angle like this in order to clear the top. So this just barely fits. The capacitor now blocks this little channel in the frame. There's a little corresponding tab on the sill, but I don't think this really serves any purpose, so I'm going to cut it off. With that piece out of there, now it'll be a little easier to get the body back on. The decoder has a couple of pre-installed wires for the speaker. I'm going to take those off. Sometimes with really small gauge wire like this, I just use my fingernails to strip the insulation. Works just fine and it doesn't break the wires. I always tin the ends of the wires before making any connections. Sorry for skipping ahead a little, but this kind of soldering was just way too fussy to do on camera. I connected all of the wires per the diagram, and all that's left now are the wires for the headlights. So there's the yellow wire for the rear headlight, white wire for the front headlight. The purple wire will be for the cab light. This actually was pre-installed, and it connects to the aux2 output from the decoder, so I'll have to map that when I get it, programmed. And then of course the blue wire, which is the common. All of the other connections, the motor, the track power, and the speaker are already done. And I taped this down, and this, just fits. Just fits. So the clearance couldn't be any tighter here. There are two red magnet wires that come out of the cab, and so I could tell them apart. I put a knot in the headlight. So this one goes to the yellow wire, and the other one goes to the purple wire. That's it for the soldering. All the connections are now done. Before I do anything else, I want to test this on a programming track. Especially with a wired install, I would recommend always testing on a programming track first before you put it on a live track. For this next part, I've put the model on the multi-scale programming track that I built in a previous episode of DCC Shop. According to the Western Pacific Railroad Museum website, WP608 has an EMD 567B prime mover. I found a file with the appropriate 567B prime mover sounds on the LokSound website. So I've loaded the sound file into the Lok programmer, and for now I'm just setting the address to 608, and I'm going to go ahead and write the sounds. One of the things I like about ESU decoders and using the Lok programmer software is that it makes programming really easy. I'm changing the name of the aux2 output to cab light, setting the light behavior to fade in and fade out, and reducing the brightness. All of this could be done with CV programming and a throttle, but it's a lot more complicated. As a bonus, I can save the settings for this model in a file on my computer. That way, if I ever have to reset the decoder, I can restore the settings in one step. All right, let's test it out. Well, that's an interesting horn. Front light works. Sound works. Rear headlight works. The cab light works. Yeah, it's running. Just as a precaution, I'm going to put some clear silicone on top of these solder pads just to protect them just in case something should try to short in there. Before I put this back together, I added some more Kapton tape to kind of try to keep the wiring away from the high spots. So there's basically no clearance above this part of the decoder, and there's also basically no clearance above the capacitor. So I'm trying to keep the wires away from that, and the resistor for the front headlight is here. Also, I taped the wires from the rear lights down the center so that they should hopefully fit in this groove. They're not very thick anyway because it's magnet wire, but still, I'm hoping that'll do the trick. So I'm probably going to reassemble this off camera because I'm sure it's going to be probably a little bit difficult. Before I put the shell back on, I want to reattach the coupler mounts, and there's a hole in these, and that should line up with the hole that's in the frame. They just snap on. Putting the shell back on wasn't quite as hard as I thought it was going to be, but you have to be really careful when doing stuff like this not to pinch any wires. Thankfully, I got everything back together. I put the model on the programming track one more time just to make sure that I hadn't messed something up while putting the shell on. All right, here we go on a live track. All right, I'm really happy with this engine. It looks good, it sounds good, and it runs good. I'm going to call it a success. I mean, it always ran well, but it's really nice to have the more updated modern sound decoder in it. I'm really impressed with the little speaker too. It sounds really good. I mean, not only does it have plenty of volume, but it also has really good tone, which in my opinion is even more important. You know, it's one thing to be loud, but just because it's loud doesn't mean it's good. So this has a nice, well-rounded tone. So, you know, between the speaker and the enclosure, it works pretty well, even though it's a really tiny little speaker. I modeled this engine with a 5-chime horn because that's how it was when I drove it back in 1995. So I picked the, I think it's a Nathan 5-chime horn sound, which sounds pretty good. Now, I don't really remember what the real one sounded like back then. Also, I don't think they actually let us blow the horn because they had some kind of a noise agreement with the town or something. But anyway, if anybody has any better information on what the appropriate horn for 608 would have been at that time, feel free to tell me in the comments. So there's still more tweaking I could do on the programming, probably tweak the motor control CVs a little bit and maybe some other things. I'll probably also turn the prime mover noises down a little bit too because it's pretty loud right now. I just left all that at the default, you know, for the moment just to kind of show how it works and so that you guys could hear it. So anyway, I'm pretty happy with this one and I'm going to call it done. So that's about it. I'm really happy to have my model of 608 running again. If you have a Kato NW2 or another small HO scale locomotive like this, then I hope you find some of the techniques I use to be helpful. If you like this video, then please like, comment, share, and subscribe. Stay tuned and thanks for watching.